You've probably heard that cryptocurrencies run on blockchain technology. Maybe you're confused about what that means. After all, blockchain for beginners is one of the most frequently searched terms on the internet. Don't worry, we have got you covered. Our explanation is dummy-proof. Honest, let's get to it. Simply put, blockchain is a distributed record-keeping technology. So what kind of records does it keep? The records are peer-to-peer transactions or data, and they can take place without the need of a centralized authority. There is no need for one singular authority because peers work to verify blocks, and each peer has a copy of the ledger. We'll explain what blocks are later on in the video. So this basically makes the blockchain an unchangeable and distributed digital ledger. A digital ledger is a digital record of data or transactions. In essence, it is simply a record-keeping system. By its very unchangeable nature, the blockchain is immutable. Therefore, you can trust it to be 100% accurate. It is not easily tampered with, unlike physical ledgers. Also, since it is distributed across multiple networks, it is protected from any network attacks. Let's look at why we even need blockchain technology before delving into the rest of the explanations. This is important. Imagine you run out of money and you want to buy dinner. You ask your friend to send you some money via bank transfer. Your friend does this, and the money he sent finds itself into your bank account. What just happened? You and your friend put all of your trust into the bank. You included a middleman into the equation and therefore included a somewhat unnecessary third party. So, what exactly is the problem with trusting this third party? This could be a question you might be asking yourself right about now. Well, what if that third party, which owns most of your assets, becomes corrupt? Goes bankrupt, freezes your assets, goes rogue somehow. Blockchain solves this problem by forgoing the third party. It is just you and your recipient. No need for someone else to be included in the scenario. The whole blockchain model was built to take advantage of trust and transparency, to be the complete and total opposite of centralization, which is the very model banks operate on. This is in fact one of the most basic requirements that make blockchain work. There is a good amount of people who have had enough of depending on a third party. There are several reasons not to, and everyone has their own reason. One of the major reasons is anonymity. So now we've looked at the basic definition and also at the problem blockchain is trying to solve. Let's move on to how blockchain actually works. You will probably hear these words being used when someone is talking about blockchain: blocks, transactions, consensus. The blockchain is made up of blocks, but you already knew that. It is a chain of blocks. Each block is filled with data. The kind of data stored depends on the blockchain type. We'll look at different types of blockchains soon. The latest and newest block becomes attached to the previous block, and so on and so forth. Another thing you should know is that in each and every block there is important data known as the hash. Simply put, the hash is there to send data to the blockchain about whether or not that specific block is authentic. It is also the determining factor on whether or not that block can be attached to the rest of the chain. The hash is unique and completely tamper-proof. If anyone tries to change the data inside of that block, the hash value will also be altered, thus sending warnings to the other blocks to not accept the tempered block. The hash is an integral part of any block, along with the other data, such as the transactional data and the hash belonging to the previous block. Let's move on to transactions. Transactions are another integral part of the blockchain. No matter the type, the transaction includes the following information: who is the sender? Who is the receiver? How high or low is the value being transferred? Last, but definitely not least, is the consensus. This is the way through which a transaction is transmitted and validated. Each blockchain type has its own type of consensus method. For example, the Bitcoin blockchain makes use of the proof of work consensus. There is also the proof of stake consensus. Consensuses are algorithms offering strict rules. Every single peer in the network has to follow these rules. These algorithms are simply a method to help peers reach a decision. The point of these consensus models is that there need to be equal rights for all participants. There also needs to be collaboration between peers, equally active participation, and finally, an agreement that benefits all participants. Before we look at a typical transaction process between peers, let's go over the types of blockchains. There are three main ones. First, the public blockchains. You've heard of the Bitcoin blockchain. Litecoin and Ethereum are also on public networks. They are large, distributed networks and are accessible to anyone willing to participate. A transaction's public info is available to everyone on the network. They are completely tamper-proof. Then there are private blockchains. To join private blockchain networks, the administrator needs to let you in. They are highly efficient. Lastly, there are permissioned blockchains. Permissioned blockchains have an extra layer of security in the form of an additional layer of control. This means that certain actions can only be performed by specific participants. These types of blockchains are popular with users who require more security and role definition. We've mentioned Bitcoin being an open and public blockchain. So, who uses permissioned blockchains? Usually, large industries or companies for whom role definition is important. For example, a manufacturer could be using a permissioned blockchain to keep track of supply chains, and he would only want a particular party of people to have access to transaction records. By now, you should know the main foundation upon which blockchains are built. Let's see a typical step-by-step process. First, the user requests a transaction. He or she could be sending payment, for example, or requesting it. This transaction request is transmitted to the blockchain network, made up of peer-to-peer computers all over the world. This huge network of computers works to solve equations that will determine if the transaction is valid and authentic. The transaction could then be either validated or declined. If the transaction is accepted, it'll be added to a block of transactions. The peers receive rewards based on the type of blockchain network for their effort. The block will then be chained to the others. The chain of blocks will grow longer. Once the block is chained with the older ones, the transaction is confirmed. Every time a new block is added to the chain, it is assigned a unique cryptographic key. For a new key to be created, the previous block's key and data are inputted into an equation. This means that the more new blocks are added, the harder it'll be for someone to tamper with them. Every new block addition makes the chain stronger and more secure. Alright, we've covered the basics and the not-so-basics. So by now, you might be wondering who uses these networks. Well, we got you covered. Let's look at its applications. Healthcare. Blockchain is used in healthcare for the secure transfer of patients' records. It is also used to keep track of medical supplies shipments, data management of electronic health records, and much more. Real estate. Here, blockchain really manages to cut costs, as it is used to eliminate the need for intermediaries. It reduces costs from process automations and makes data more accessible to help increase transparency. Cross-border payments. Payments made on the blockchain require only the sender and receiver. No fees need to be paid to a third party, such as a bank. Thanks to blockchain networks, these payments are more reliable, faster, and ultimately more traceable. Identity security. Most of the world currently stores valuable personal identification in centralized databases, such as those of the government. Blockchain allows people to take control over how they choose to share and store their identities. Since having a secure identity is crucial for gaining access to education, applying for jobs, opening a bank account, and more, a decentralized data system would seem more wise, where you are in charge of your own data. Crypto transfers. Blockchain technology was created for Bitcoin. Cryptocurrency would not exist without blockchain networks. Satoshi Nakamoto, the creator of Bitcoin, believed that banks had too much power. This was his invention, a blockchain network where you can send and receive payment without the need for a centralized authority. We hope we have demystified the nature of blockchain and convinced you to delve even deeper into the topic. We have a full guide up on cryptomy.com for you to read, along with countless other guides ready to kickstart your crypto and blockchain journey. If our explanation has helped you, don't forget to like this video and subscribe to our channel. We will see you in the next video.